Hello friends, welcome back to my channel. Today I would like to talk about primary amines, nitriles and hydroxynitriles. Amines are compounds with the amine NH2 functional group. Amines are organic compounds containing nitrogen derived from ammonia NH3. Amines are classified as primary, secondary or tertiary amines depending on how many of the hydrogen atoms in ammonia have been replaced by organic groups. The diagram below shows examples of aliphatic and aromatic amines. Examples of aliphatic amines include methylamine, dimethylamine, trimethylamine. Aromatic amine example is phenylamine. Physical properties of amines. The amino group dominates the physical properties of short-chain amines. Hydrogen bonding takes place between amine molecules resulting in higher melting and boiling points than alkanes of comparable relative molecular mass. Solubility in water. Amines with fewer than 6 carbon atoms mix with water in all proportions. As with other polar functional groups, solubility of amines in water decreases with increasing carbon chain length as the nonpolar contribution to the molecule becomes more important. Amines acting as bases. Amines are the organic bases. They are weak bases because they only partially associate with protons. RNH2 plus H plus gives RNH3 plus. The basic strength of an amine measures its ability to accept a proton. This depends upon the size of the negative charge on the amino nitrogen atom, the availability of the nitrogen lone pair. Production of amines. They can be produced as a result of nucleophilic substitution reactions of halogenoalkanes when they are heated under pressure with ethanolic ammonia, that means NH3 in ethanol. As you can see here, the reaction of bromoethane and alcoholic ammonia in presence of heat and pressure gives you ethylamine and HBr. Nitriles and hydroxynitriles. Formation of nitriles. Nitriles are formed when a halogenoalkane reacts with cyanide. The reaction requires warm ethanolic potassium cyanide. Ethanolic means dissolved in ethanol. The reaction is shown over here. Bromoethane reacting with cyanide ion to form propane nitrile. Formation of hydroxynitriles from aldehydes and ketones. The reaction is nucleophilic addition with HCN. Aldehydes and ketones also undergo addition reactions with HCN, which is hydrogen cyanide. In these reactions, addition of HCN takes place across the C double bond O bond. However, the attack is by a nucleophile, not an electrophile. We can show this using the nucleophilic addition reaction of the aldehyde propanal when heated with HCN. The HCN is generated in situ, that means in the reaction vessel, by the reaction of potassium cyanide, KCN, and dilute sulfuric acid. Hydrogen cyanide is not used alone because it is a poisonous gas. Instead, it is produced from the reaction between sodium or potassium cyanide and sulfuric acid. The solution will contain hydrogen cyanide and some free cyanide ions. The reaction is shown here. For both aldehydes and ketones, hydroxynitriles are produced. For aldehydes, take ethanol as an example, 2-hydroxypropane nitrile is produced. For ketones, take propanone as an example, 2-hydroxy2-methylpropane nitrile is produced. And the mechanism is also shown over here. Hydrolysis of nitriles. This is a chemical reaction of nitrile. Nitriles can undergo hydrolysis to form carboxylic acids. The C triple bond N nitrile bond reacts with water to produce the carboxylic acid. It can take place via acid hydrolysis. The nitrile is heated under reflux with a dilute acid such as hydrochloric acid. A carboxylic acid and a salt are produced. The reaction of a propane nitrile with a dilute acid is shown over here. Propane nitrile under hydrolysis gives propanoic acid and ammonium chloride. Alkaline hydrolysis. The nitrile is heated under reflux with an alkali such as sodium hydroxide. This produces a carboxylic acid and ammonia. The reaction takes place in two stages. First, carboxylate ions are produced. Example, sodium carboxylate forms if sodium hydroxide is used. A strong acid must then be added to provide hydrogen ions to liberate the carboxylic acid. Hydrochloric acid is commonly used. The formation of propanoic acid from propane nitrile is shown in two stages. As you can see here, stage 1, propane nitrile reacts with alkali to form salt of propanoic acid. In stage 2, the salt of propanoic acid reacts with HCl and forms propanoic acid and NaCl. That's all. Thank you so much for watching this video.